Hey there, welcome back. So in the previous video, I have given you an introduction to tensors. So now you know that tensors are nothing but the fundamental data structure in PyTorch, and the data structure is of the form of a multidimensional array. So it's basically data stored in a multidimensional array. So in this video, what we are going to do is we are finally going to get started with some hands-on with tensors. So basically there will be 4 to 5 videos in a series, and you are going to see, how you can create different tensors in PyTorch, what kind of operations you can do on top of tensors, and finally the interoperability between tensors and numpy nd arrays. And we will also see how you can create tensors in GPUs towards the end of this section. So let's not waste any more time and fire up the Jupyter notebook and get started. So here, as you can see, that I am in my Jupyter notebook, and this is pretty much the same notebook which we created while testing, if the torch import is successful or not in the environment setup video. So let's only continue here. And what I have done is, just to save your time, I've written all the code that we are going to need in this entire video. And now what I'm gonna do is I'll just run them one by one, and I'll tell you what does it mean, right? What each line of code means and where you can really use it. So in the first 2 lines, we don't do much. We just import the PyTorch library, and then we see the version of the library that we have installed. Now in our case, the version is 1.7.0. Now it may be different for you based on which version you install. Now before creating any of the tensors, let us first see what is the default data type of our PyTorch library that we have, right? And just to mention, where will you use this default data type? So basically, when you create tensors, there are 2 different options. One option is to specify the data type, and the other option is to not specify the data type. So if you specify a data type, for example, say integer or float or something like that, then the data type you specify, the tensor will have the same data type, right? But if you don't specify a data type, then the default data type will always be selected. So in this case, as you can see, that the default data type of the PyTorch library is torch.float32. Now there is also an option in which you can change the default data type, and that you can do using the function called set default data type. So here you can see that in the set default data type function, we have written float32, but let us change it to say float64. So when you write it as float64, and if I run this, you can see now the default data type changed to float64, right? So this is such a way, it's like in which you can change the default data type. So now if you create any of the tensors, and if you don't specify a default data type, then this will be the data type of the tensor. Now there is also a limitation to setting the data type for the default, like the default data type for the tensor, and that is you can only select a floating point data type. So if you try to set something like torch.int, then it will throw you an error, and the error is only floating point types are supported as the default data type, right? So you can only select something in the range of float. Now these are some data types that we talked about, data types like float32, float64, torch.int. Now there are tons of other data types in PyTorch you can check out, and for that you can go to this link called pytorch.org/docs-table-tensors.html, and this page pretty much has a list of all the data types which are available in PyTorch. So here you can see that we have 32-bit floating point number, which is the default data type of PyTorch. Then we also have 64-bit floating point number, we have 16-bit floating point number, which is also called torch.half. Similarly, we have torch.int, we have torch.short, which is nothing but int16, and all these things. So just go through this page once, and you will just get the heck of what are the different data types which are available for you. Now coming back to tensors, so now we have the idea about the default data types and all these things, and also like what are the different data types of tensors. So now let us create some tensors. Now for creating tensors, there are tons of methods in PyTorch in which you can do that. So for now, let us just create a plain old tensor by calling the torch.tensor function, and in that function we are going to pass a list of list, or I should say a 2-dimensional array, something like that we are going to pass. And here you can see that in the list of list, the first inner list contains 1, 2, 3, and the second inner list contains 4, 5, 6. So if I run this, it creates a 2D tensor in which the first row contains 1, 2, 3, and the second row contains 4, 5, 6. Now if I check the D type of this tensor, that I can do by calling this keyword inside the tensor1, which is called D type. So if I call this, then you can see that we get torch.float64, since we selected the default data type to be float64. Now this was an initialized tensor in which you had specified what will be the values in the different different rows and all that. You can even create an uninitialized tensor, and the way you do it is basically you call the same torch.tensor function, and this time instead of passing the values you pass the shape of the tensor. So here we have specified 3,3, which is basically a 3, so this will create an uninitialized tensor of size 3 by 3. So here you can see that for all the values we basically have some junk values. There's like these are not some values that we have selected, right? And now again if we check the data type of this tensor, we will again see that it is float 64, because again this is taking the default data type. Now we can also create tensors from a random distribution, because if you remember the neural network section, I have said that in case of neural networks, when we create weights and all these things, then like when you start training the neural network, then for all the weights and biases you randomly initialize them. So the way the weights and biases are randomly initialized is by calling this rand function. So here you can see that I'm calling a function called torch.rand, and here I'm passing the shape of the tensor. So this is going to create a tensor of size 2 by 3, which contains basically 2 rows and 3 columns, and it will have all the random values between 0 and 1. So here you can see that it created the tensor and we have the values in the same range, right? Now this again has the same data type, right? Because we are not specifying the specific d type, but if you want you can even specify a d type here. For example, in the second one, what we have done is we have specified a data type which is float 32, right? So if we just run it, you can see that it created a separate tensor, and this time the data type is float 32. Now similar to rand, there is also another function which is called randn. So this time what it will do is it will basically create a similar tensor, but instead of giving all the values between 0 and 1, it will take the values from a random normal distribution. So this is pretty much how a random normal tensor will look like, right? Now apart from these, you can also create other tensors, for example integer tensor, and this time all I'm doing is I'm just calling the torch.tensor. I'm passing the values of the tensor and finally casting it to torch.int. So this is again something you can do. There are also other specific like functions using which you can create specific tensors. For example, for creating short tensor, you can call this torch.short tensor function. For creating a half tensor, you can call this half tensor functions, and so on. There is even a function by which you can have a tensor of a size of your choice which contains just a single value, right? So in all the places in the tensor it contains the same value. So that you can do by calling this function called torch.full, and the first parameter is basically the shape of the tensor, and the second parameter is the fill value, and the third parameter, which is again optional, which is the d type of the tensor. So if I run it, you can see that I get a tensor of size 2 by 3, and it contains in all places it contains the value 10, because here the fill value is 10. Now there are even functions in which you can create a tensor out of another tensor. So for example, you have a specific tensor of a specific size. Now if you want to create another tensor of the same size which basically contains ones, that you can do by calling this function called ones like, right? So here you have tensor ones, and so here tensor ones is going to be of the same shape as tensor full, but it will have only ones. So that we can do by calling the function ones like. So in ones like, we have just passed the tensor full as a parameter, and if we run it, you can see that we get tensor ones, and which is full of ones. Similar to ones like, you also have zeros like, then again all the values will be zeros. Now there are some more utility functions for tensors. For example, you can create an I tensor by calling torch.I by just passing the number of rows and columns. Now in this case, for I tensor, rows and columns are same, so you just pass it just one argument, right? And you can see that all the diagonal terms have value 1, right? Similarly, you can even create a tensor that contains values within a range, right? So this pretty much works the same way as NumPy's linspace works. So here you have torch.linspace. So we are starting at position 1 and we will end at position 10, and we have 5 steps. So this is going to create a 1D tensor, and the starting point and the end points will be there, and we'll go for a step, like there will be 5 different values since we have 5 steps. So here you can see that the first value is 1, the second value is 3.25, the third value is 5.5, the fourth and fifth, like as they should, right? So you have 5 steps implemented. And finally, there are also ways in which you can create a sparse tensors. Now these are some things which are really important and really needed in case of a lot of different calculations, and that's why that's why you should know about them. So the way you create a sparse tensor is quite like this. So the first thing what you do is you specify the index. So what is an index? So the index is basically a tensor, which will specify that in which indexes the sparse tensor will contain values. So if I just create this index, so you can see that it contains 3 3 1 2. Now the way you read it is quite the opposite, so it will be 3 1 and 3 2. So this basically means is at the position 3 1 and 3 2, the sparse tensor will contain some values. Now again, the values are pretty much like this. So as you have said, like as you have seen that we have just 2 coordinates over here, and for the 2 coordinates we can only have 2 values, so we'll have the values tensor here as well. And finally we can create a sparse tensor by calling this function sparse co tensor, and here we pass index, values, and the shape of the entire sparse tensor. So I'll just run it, and you can see that the tensor got created. Now this tensor pretty much looks like this, and from this you can even see that you have the index terms here like 3 1 3 2, and you have the values as well, the size as well, and all that. But if you want to see the sparse tensor in its dense form, then what you can do is you can just call this function of the sparse tensor called toDense, and if you run it, you can see this is the dense version of that tensor. Now this is a 4x4 tensor, so you have 4 rows and 4 columns, and you can see that at position 3 1 and at position 3 2 you have the values 1 and 5 respectively. So these are pretty much the different ways in which you can create tensors. Now in the next video we are going to see that what kind of different operations you can do on top of tensors and so on. So I will see you in that one. Thank you.